Welcome to this session on architecture-based development. In this session, we will explore the role that architecture plays in software development and how it serves as the backbone for building complex systems. We will delve into the concepts, principles, and practices that form the foundation of architecture-based development, illustrating why it is indispensable in modern software engineering. Imagine we want to build a palace. The process doesn't simply start by simply gathering bricks and wood or hiring as many masons and carpenters as possible. We could build maybe small walls or a very tiny house, but not a complex big building. The important thing here is that we need to start with a carefully considered design, a sound architecture. For this, we need an architect or an architecture design team who can visualize the system, who can provide the sound architecture of the system, which can then be further detailed and based on which the overall building can be developed. And this analogy exactly also applies to software development. Let's start by defining architecture. According to Webster's dictionary, architecture is the art or science of building, particularly the design and construction of structures. However, architecture extends beyond physical structures. It also refers to the organization or construction of any complex system, whether it's a garden, a novel, or a software system. Architecture as a concept is universal and can be found in many fields, whether it's building architecture, car architecture, computer architecture, or even plane and bridge architecture. Each of these requires careful planning and design to ensure functionality, safety, durability, and other quality factors. Similarly, in software, architecture also provides the blueprint that guides the development of systems to ensure that all components work together cohesively and the proper system is developed. In the context of software, architecture refers to the fundamental organization of a system, its components, their relationships, and the principles governing its design and evolution. This definition, as outlined by the ISO IEC IEEE standard, highlights the importance of the rationale behind the architectural design decisions, which profoundly impacts the system's quality attributes such as performance, security, and scalability. If you look at the current large-scale software systems, we can see that they involve many people working on the same problem, often dealing with millions of lines of code. These systems are inherently complex and must be also delivered on time and within budget. A common misconception is that adding more programmers to a project will accelerate its completion. In such cases, simply coding isn't enough. While coding is a critical part of software development, it is definitely not sufficient on its own, especially for large-scale systems. Fred Brooks famously stated in The Mythical Man Month the following: adding manpower to a late software project often makes it later. This highlights the importance of having a well-defined architecture from the outset, which can prevent projects from becoming delayed, over budget, and often with low quality. Similarly, Edsger Dijkstra, a Dutch pioneer in computer science, emphasized the importance of structure in software systems. He argued that the correct arrangement of software system structure is essential before any programming begins. This concept led to the development of so-called layered architectures. We will discuss this later, where he actually grouped the system as a set of layers to actually simplify the development and maintenance of systems. Dijkstra's insights also laid the foundation for many of the architecture principles that we use today, emphasizing that structure should guide the development process. Obviously, over the decades, the nature of software problems has evolved significantly. Initially, software was primarily concerned with solving algorithmic problems. This could be often done, for example, by a single programmer. However, as technology advanced, software also began to handle more general purpose applications, and it was also applied in different application domains. This increase in complexity, with systems growing to millions of lines of code developed by many people, has made it nearly impossible to develop systems without a solid software architecture. Today, as such, architecture is essential to manage the complexity and enable us to build systems that are scalable, reliable, and adaptable. Similar to other systems, we need an architect in the software development process, an architect, a software architect or software architecture team. This software architecture team is responsible for the overall design and realization of the software architecture, which will ensure that all components work together harmoniously. The software architect bridges the gap between design and implementation. The architectural design can be further used to do the detailed design, which in its turn can be used to develop the application during the coding process.